Hello, so this is going over the circuit practice problems. If you have not already done them, make sure you go and do them first. There's certain places where I'll pause, then ask you to come back. That way you can check yourself and maybe write some misconceptions before you continue. It'll make it a little longer, but it'll also help you understand it much, much better if you do it this way. Alright, so again, you should have already done 1, 2, 3, 4, and 5, I believe. So, number 1 is a 30 ohm resistor is connected to a 10 volt battery. Calculate the current. So, your justification would be under the Ohm's law, because that is Ohm's law. Ohm's law is V equals IR, so that's voltage equals current to time resistance. So, we have a resistance, we have a voltage, and we wanted to calculate the current. And so normally the easiest way, if you're not sure which way this is supposed to go, there's something that's called like the triangle, like you can do a little triangle. Basically, the idea is I and R will multiply to find V. V divided by R, I gets you R. V divided by R gets you I. And so since we are trying to find I, we are going to do voltage over resistance equals current. And since that's 30 over 10, that's going to get you 3 amps of current. For number 2, so it says we have a 48 ohm resistor connected to a 24 volt battery. So again, would look like this. So a 24 volt battery connected to a 48 ohm resistor. But the main thing is, well, what if we replace this with a larger voltage? What would happen to the resistance in the resistor? Well, nothing. Because the resistor it's a resistor, it's a physical object. So if you were in class, you'd actually get to play with a resistor. But a resistor is a physical object. So no matter how much you change the battery, you're not going to change the physical object. So it would remain the same. As for the fact, resistance is provided by a resistor, a lamp, or any electronic device. The units of resistance are ohms. And so this would be under definitions of voltage, current, and resistance. So I'm not going to write the whole thing out, but you should, or hopefully you wrote some abbreviation of it. Basically, since the resistance is provided by an object, you can't change the object just because you change something else. The third one, you're looking at these two circuits. Sorry, they're a little blurry, but the question is, we have these two circuits, and which one is a 5 ohm resistors connected in series with an ammeter? An ammeter is just something that measures current. You'll see them listed on these a lot of times, but there's nothing special about it. That's where it's measuring the current. So which one of these is in series? Hopefully you could identify that this is the series. So it is A only. As far as your fact, it should be that resistors in series are connected in series if they're connected on a single path, which is under resistors in series. Moving onward. Right, and then if you are truly following the instructions, this is where you should stop watching this video and go back and continue doing questions 4 through 7. Alright, so hopefully you are back and you did take that break. So for number 4, we're saying a 100 volt battery. So again, if you're ever not sure of like what you're reading, really try to draw the picture. And so it says they are connected in series. So that means they're on the same path. And the question is calculate the equivalent resistance. So hopefully you remember your justification or something, or you could find it, and that is to find the equivalent resistance of series resistors is the sum of all the individual resistors. And so remember, sum is just a fancy word for add them. So if the resistance is 70 and then 30, the total resistance is just going to be 100 ohms, justified with the fact we said before. For number 5, which resistor carries a larger current? And so this is the exact same one for all of these, so I'm just going to redraw it. So it was 100 volts, a 70 ohm resistor, and a 30 ohm resistor. And so which resistor carries a larger current? Well, it's only one path, and current is the flow of electrons, so they can only have the same current. And so that would be the fact of series resistors each carry the same current, which is equal to the total current throughout the circuit. And so that would be the fact that you would use for this. And then which resistor takes the larger voltage across it? This one can be a little bit trickier. So the voltage across series resistor is different to each, but adds to the total voltage of the battery. And so if we're thinking about Ohm's law, you can say, well, okay, they have the same current, but Ohm's law is V equals IR. So they have the same current, this is a constant, but if this one has more resistance, that means it gets more voltage. And so you can also think about this as, well, the more resistance it has, the more volts, the more energy it's going to take to get over that bigger resistance. So it'd be that 70 ohm using, that's why I said justification with an equation or a false calculation. So the idea that, yeah, they have the same current, which is what we said earlier, and therefore this would be true. And then after that, calculate the total current in the circuit. The easiest way to do total current in a circuit is use the total voltage in this case, and so that's why I say using a table value. So my total voltage is 100 volts. We don't know my total current, but I do know my total resistance, or my equivalent resistance, which we figured out for number 4. My equivalent resistance was just if I added all of them up. And hopefully you're kind of getting an idea of, well, if this is 100 and this is 10, if I plug this in to this equation, or if this is 100 and this is 100, the only way is if the current is 1 amp. And so make sure you're using your units. Units can be extremely helpful with circuits. I know it does get confusing learning them, but the more you practice, the easier it gets. Alright, and again, hopefully if you finish those, you should stop the video, go back, correct any mistakes you made, and continue. So when I say correct, I don't mean erase your old work, but because I do want to see your original work. So if you typed anything, that's fine. Just like write under it, you know, a different color, bold, something. Just because the act of correcting will better cement it in your memory. And you don't have to do all of this at once. In fact, I highly recommend you take breaks. But again, please go back and then go back and do, I believe it's 8 through 11. And then check your answers. Alright, so now that you've already done 8, 9, 10, and 11, please come back. And so we're looking at, we have this circuit, has a 10 volt battery connected to a 70 ohm and a 30 ohm resistor. And so you might notice these questions get a little repetitive, but hopefully that made this extremely easy. It's you just add them again. Alright, so it would be 100 ohms. And your justification again is that series or resistors in series, the equivalent resistance of a series circuit is the sum of the resistors. As far as calculating the current through the circuit, remember this is a 10 volt, not an 100 volt, so it's going to be a bit different. But you would still want to use a calculation here with the total voltage and the total or equivalent resistance. And so if you do this, you're going to get 0.1 amp please make sure you are keeping your units. And so I said estimate the voltage. You don't have to calculate it. You can calculate it. But you want to think of it this way, is if I have 10 ohms, or excuse me, if I have 10 volts, we know that the total voltage of the two resistors adds up to 10. So we know that it has to be less than 10. And we do know that the bigger one is going to take more voltage. The exact answer is 7. But if you guessed something less than 10, but greater than 5, I would give you credit for this. So your answer should be greater than 5, but less than 10. Alright, and then it says estimate the voltage off the 30 ohms. So since I wrote 7, I would do 3 ohms, but basically it needs to be whatever you guessed in your answer for the last one from 10. So if you answered 6, it should be 4. If you answered 7, it should be 3. If you answered 8, it should be 2, 9, 1. And those are the only answers you could have done. So again, this should have been something that added up to 10 volts with the other one. And that's just because that the voltage, so if you look back at resistors in series, the voltage across series resistors is different for each, but adds to the voltage of the battery would be your justification. 12, if the 10V battery, or the 10 volt battery, was replaced by a 15 volt battery, would the current through the 70 ohm resistor increase, decrease, or remain the same? It would definitely increase. Alright, and the reason for this is, again, the 70 ohm resistor is not changing. So our resistance here is a constant. So if I increase the voltage, my resistance is a constant, so that means my current must have increased. So more voltage makes more current. So you can think of that as we're putting more energy through our circuit, which makes our electrons go faster. And that's why I said equation or false calculation. So you could have plugged in 15 volts and found the current, and then done 10 volts and found the current. And hopefully you can see that 10 divided by 70 is less than 15 divided by 70, so that's an increase. Alright, so hopefully you have done this. Stop, go back, look at your mistakes, see what you need to fix, and move onward. Come back to me after you've done, I think, through 17. Alright, so we're under the assumption that you have stopped. We're going to quickly just do the rest of that. So 13 is just draw this circuit. So I did write, this is if you were going to draw them on the computer, that's how you do that. If you wrote it on a piece of paper, that's fine too. But to draw a 18 ohm and a 36 ohm resistor are connected in parallel. So notice everything we've been doing before with series, this is parallel with a 24 volt battery. A single ammeter is placed to read the total current. So for this, that means we had a 24 volt battery, and these must be connected on two different paths because they're in parallel. So parallel means we need two different paths. So it doesn't matter which, but one's an 18 ohm and one's a 36 ohm. The ammeter is going to be less of a big deal, but if I want to read the total current, I can't place it on one tiny line or another line. It has to be on a main line, which could either be here or here. It just can't be, it has to be on a line that the 18 and the 36 share. So an electron has to pass through there to get to either one. Alright, and then as far as that circuit we drew, what could be the equivalent resistance? So remember, justification is for parallel, the equivalent resistance of parallel resistors is less than any individual resistor. So we had an 18 ohm resistor and a 36 ohm resistor, which means for my equivalent resistance, it has to be less than both 18 and 36. So the only answer that is less than both of them is 12. All right, is the voltage across the 36 ohm resistor greater than the voltage across the 18 ohm, less than the voltage across the 18 ohm, or equal to? The answer is equal to, and that's because, again, for a fact of resistors in parallel, the voltage across parallel resistors is the same for each and equal to the total voltage. So our battery was 24 volts, so this resistor gets 24 volts and this resistor gets 24 volts, so they are equal. And so if you know that, you can now calculate the current through the 18 ohm resistor, because I know the voltage is 24 volts. I know we're looking for the current, and the resistance is 18 ohms. And so when you calculate current, you are perfectly welcome to leave it as a fraction. You can simplify this fraction, of course. This would be 4 thirds if you want. I prefer fractions over decimals, but you're welcome to turn them into it. And so again, this is just by dividing 18 on both sides. All right, and then it says, is the current through the 36 ohm resistor greater than the current through the 18, less than the current, or equal to the current? And so justifications with an equation are false calculations. So what you should know about resistors in parallel is that parallel resistors each carry different currents, but it does add up to the total. So remember, we already calculated that for the 18 ohm resistor, the current was 4 thirds amps. That was the last problem. And so we could do the exact same thing, or you could do a false equation, but the idea is that, well, we know that the voltage is the same for both. It's 24 volts. The resistance is not. So if my resistance, so if this is constant and my resistance goes up, my current goes down, because the more resistance you have, the less well the electrons flow. And so the answer would be less current. And again, you could also have plugged in the numbers, which would be 24 volts equals the current times my 36 ohms, and we could divide 36 ohms, and we would get 4 over, this is taking me way too long, divided by 6, 4 over 6, or 2 thirds. So obviously 4 thirds is bigger than 2 thirds. All right, go back and definitely, especially this one, because I feel like we introduced a lot parallel resistors on that one, so go back and check your answers, really think about them, and then move on and do 18 through, I believe, 21, 22. All right, now that you have done 18 through 22, let's take a look at 18. So 18, the diagram shows 2 parallel resistors and 3 ammeters. So this ammeter measures the total current, and this is just the current in resistor 1, and this is just the current in resistor 2. So this is the resistor 2 current, and this is the resistor 1 current. And so the idea is that, well, our fact for resistors in parallel is parallel resistors each carry different currents, but they add up to the total. So this is my total. If this one is 4, this must be 6, because when they split, if I started with 10, I still have to end with 10, even if I just separate it out into different spots. So, because the charge is conserved, so the amount of electrons, the flow is really a measure of how many electrons are flowing at a certain time. And so if I have 4 on one side and I started with 10, there has to be 6 on the other side so that I still add up to 10 again. Alright, and this one's a little trickier. And so remember, we had 10 amps and 4, sorry, my pen's not working great, 4 amps and 6 amps. Okay, I put the original because it's much better. And so that was only 6 amps going through that one. And so they asked, what is the voltage of the voltage source? So you might be like, well, how am I supposed to know that? Well, there's a couple things you can do. Well, I would probably use this one just because, let's say you're not sure if your first answer was right. But again, we have a resistance and we have a current. The reason you cannot use this one because you don't know the total resistance. You only know each individual resistor. And so, and that's okay. There's a way to calculate it, and if any of you are like good at math, you're welcome to go for it. It's very easy to find. I'm not going to teach it right now. But you do have the current and the resistance here, and then remember the voltage through each parallel is going to be the same as the total voltage. So you can still use V equals IR here. You just have to be really, really careful which V, I, and R you will use. It's just the trickier part with this. So I'm going to use the 30 ohm resistor times the 4 amps, which is going to get me 120 volts. We could have also done this with our 6 and 20, because we would say, well, that's 6 amps, and that's a 20 ohm resistor, and that still gets us 120, and that's actually a way you can like fact check yourself as well. They both worked, so we did a good job. So the voltage source must be 120 volts from that. And then you would also want to say that that for parallel resistors, the voltage across parallel resistors is the same for each and equal to the total voltage. As far as which resistor takes more voltage across it, it's both the same. It's the same. Right? They're both 120 volts. So again, stop, make sure you check over your answers, and then continue. Alright guys, in the home stretch, so again, make sure you have done 21, 22, 23, I think. So looking at this, look at the circuits shown above. This one. The voltmeter V2 reads 80, and was the voltage reading of V1. Alright, and this one is kind of a tricky one. So you might be like, well, I have no idea. Well, remember, we do know that these voltage readings, that if I have more resistance is going to mean it needs more voltage. So if this one has more resistance, well, it's going to need more voltage than this one. And so this one's 80, that's less than 80, that's less than 80, that's equal to 80. So it's got to be 160. And so the best justification for this is the idea that voltage across two resistors is different for each, but adds the voltage of the battery. But you also want to think of V equals IR. You can say voltage equals the current times the resistance. And another way to think about it is we can see that that's 20 and 40. So if I double my resistance, it's going to double the voltage. And the original voltage was 80, so double of 80 is 160. Alright, 22. A resistor is connected to a battery. The battery's voltage is varied without changing the resistance. The graph of voltage versus current is shown above. Use Ohm's law with the point on the best fit line to calculate the resistance. Calculate the resistance of the resistor. Alright, so this is a little trickier. So the idea is that my resistance is constant. And so this is actually kind of how you prove Ohm's law. Is the idea that, well, we write it like this, but this is my y, this is my x, so y equals mx plus b. Our b is 0 because the point slope intercept is 0. And so that makes, so we can see that this is the y, this is the x, meaning the slope of this line is the resistance. And so remember, slope is y, change in y over change in x, if our beginning is 0. So basically we want to find the slope of this line. I would probably use this point up here that you can barely see up here, just because it's really pretty on exactly 0.8 and 20. So my rise is I went up from 0 to 20, so I went up 20 volts. My run is 0.8 amps, and you can either leave it like this or you can use a calculator, which will tell you that if you put that in, it's 0.25 amps. Alright, and then we have next one, a 36 ohms connected to an 8-volt battery. The battery is then replaced by a battery that provides a larger voltage. What happens to the current? So remember, we said that no matter what I do to my battery, my resistance isn't going to change, and vice versa. No matter how much I change my resistors, my battery, my voltage provider, isn't going to change. The one that will always vary is actually your current. So if I increase my voltage, I am going to increase my current. And so you can use this using you can use a dummy calculation or some sort of V equals IR justification from that. So that's Ohm's law. Alright guys, we're so close to the end. Just 2 questions. So 24, a 16 ohm resistor is connected to a 3-volt battery. The 16 ohm resistor is replaced by a smaller resistor. What happens to the voltage? So I kind of already insinuated, but the battery does not change the resistor. Your resistor is not going to change your battery. The thing that gets changed is your current. So nothing happens because you're not changing your battery just because you just because you decrease the resistance is not going to affect what battery you're using. If you're using a 3-volt battery, you're using a 3-volt battery. What's going to happen, in fact, is that you're going to increase the current when you do that, but the voltage will remain the same. Alright, we have a 50 ohm resistor is connected to a 16-volt battery. The 50 ohm resistor is placed with a smaller resistor. What happens to the current? And we just said that. But the idea, again, is that if I decrease the resistance, it makes it much easier for the current to flow or for electrons to move through the circuit. So even though we don't know what the number is, we know that the current will increase. And again, this is based on Ohm's law. So congratulations, pat yourself on the back, you're done. I would like... this is for extra credit if you paid attention this far, because I know this was a long process. Please write a short private comment on this assignment when you turn it in about what parts you still don't understand or what you felt were the most difficult parts, and I will give you extra credit when you take the circuits quiz. So if you want to prep for the circuits quiz, the best way to do that would be reviewing this, checking your answers, going back and correcting yourself, and then when you feel ready, please take the circuit quiz. Good luck.